Welcome everyone. This is the first lesson recording for IM2, April 26, 2021. Goal for the day. We are going to be studying portions of a circle. And to get us started, we're going to get back to our favorite food, or at least one of my favorite food is pizza. Who doesn't like pizza? What portion of pizza is gone? Can you tell me in private chat? Well, if I was to reproduce the same amount that is gone and put it there, and I can actually fit 4 identical pieces evenly, that means the amount that was gone, each of the pieces represent 1 out of the 4 pieces, so 1/4. It's a fraction, okay, and that's what fraction represents. Okay, how about this? What portion of the pizza is gone? What do you think? Well, if I copy the same amount and put that together, I can see that 3 of the identical amount makes up the whole pizza. So it's 1 of the 3 pieces that makes up the whole. So we say it's 1/3. Again, it's a fraction. Okay? What about C? What portion is gone? Well, if I copy the same amount, copy it onto here, here, and here, and then 5 pieces, what happens? It's not quite right, is it? It does not fit 5 identical pieces evenly, so it is not 1/5. Okay, so maybe you tell me some other numbers. So we know that that is not 1/5, and so we were just eyeballing it. We would really like to find more accurate measure of how much of pizza we are dealing with. And again, we're going to be dealing with fraction because that's what fraction tells us. How many parts when the whole is divided by however many parts do we have. Okay, so in this case, what is the fraction representation of the missing piece? What about this? What is the missing piece? Well, the essential question we want to ask is, how do I accurately know what portion of the circle any arbitrary slice is? Okay, so to do that, we are going to be exploring this GeoGebra activity, which is this. Okay, so here you can move C around to change the central angle and see how the portion changes. Okay, so you can have obviously no amount, 0 degrees, or a quarter, which will be 90 degrees. Okay, remember we have 360 altogether. Full revolution is 360. So we can divide, you can divide the 360 into 4 parts by putting in 90 degrees, or into 8 slices. So if I divide 360 divided by 8, that would be 45 degrees each. Or if I was to divide the pizza into 3 equal parts, then it would be 120 degrees. Or 2 halves, maybe half pepperoni, half cheese, that will be 180 degrees, and so on. So the angle measure at the center is a really good way for us to be able to tell what portion of the whole pizza we are dealing with. So we use the ratio of central angle to 360 degrees to calculate the portion. So in this case, if we just measure the angle it makes at the center, and if I use my protractor and measure this as 80 degrees, I know that this is the portion that is missing is 80 degrees out of the 360. 360 degrees is the whole pizza. Okay, 80 is the portion that is missing. What about this? Okay, we don't know what the measurement is, but if I measure it to be 130, the portion that is missing is 130 degrees divided by 360. Okay, and I can simplify these fractions further. And what about this? Okay, and if I know that this angle is 30 degrees, That's going to be 30 divided by 360 degrees. And can I simplify each of the fractions further? Well, simplifying fractions, you look for numbers that is divisible by both top and the bottom of the fraction, so the numerator and the denominator. I know that 0 is there, 0 is there, that means I can divide top and bottom by 0, so that cancels out. Looking at 8 and 36, I can start by looking at what is well, they're both even, so I can divide the top by 2, which becomes 4, and 36 by 2, and that's going to be 18. Okay, they're still even, so I can divide that further by 2, and that divide by 2 again, so that's 2/9. So this 80 over 360 is equivalent to 2/9. So I can say I am missing 2/9 of a whole pizza. What about this? Simplifying, I can get rid of the zeros and 0. That is just by dividing both top and bottom by 10. 13 and 36. Is there a number that is divisible by both 13 and 36 evenly? Well, 13 times 2 is 26, and times 3 is 39, so it's not going to be 13, and 13 is a prime number, so there are no other factors, so the simplest form is 13 over 36. In this case, I have 13 over 36 of a pizza that is missing. What about this? Again, I can divide both top and bottom by 10. 3 and 36. Is there a number I can divide both top and bottom by? Yes, that's 3. If I divide 3 by 3, that becomes 1. 36 divided by 3, that's going to be 12. So 30 over 360 is equivalent to 1/12. So I can say I am missing 1/12 of a pizza. Now, if I asked you the central angle measure here, which is 60 degrees here and 45 degrees here, and asked which slice is bigger, what did you say? Well, you can't really tell, can you? Because even though A is you have a bigger angle, its portion of it's of a smaller size pizza. So the angle, having the same angle measure alone, is not going to be able to help me to find the area of each slice to be able to compare. Okay, so the angle measure alone is not enough. Instead, what do we need? We also need radius or diameter of the circle as well. Okay, so now if we are told the radius is 10 inches for this, and we are given 60 degrees, and radius is 12 inches, and you are told that this is a 45 degrees. Can you tell which slice is missing, which is a bigger piece that is missing? Well, we need to figure out the missing piece area, right? So how do I do that? Well, the whole pie or whole pizza, the area of a whole pizza, so area of the whole pizza is going to be pi times r squared. What is r? We are told that is 10. 10 squared, which is 100 pi. Pi inches squared. Okay, so then what is the area of the missing? We're really dealing with just a portion of the whole. And we're told that we have 60 degrees. So we have 60 degrees. And what is the whole revolution? That's 360 degrees. So we have 60 degrees out of possible 360 degrees of pizza. And I know that the whole pizza will be 100 pi inches squared. So if I simplify this, again, I can simplify the fraction by dividing top and bottom by 10. Looking at the 6 and 36, I can divide both top and bottom by 6, and that leaves me with 1/6. So 1/6 multiplied by 100. They are both even numbers, so I can divide them by 2. So that's 50 here, and this is 3. So the simplest form is 50 over 3 pi inches square of pizza is missing. What about in this case? Let's calculate the area of the hole. Is pi times r, in this case 12. So 12 squared is 144 pi. So area of the missing in this case is going to be, we're dealing with 45 degrees out of possible 360 degrees multiplied by the whole pizza is 144 degrees. That's what, if I had the whole pizza, that would be the area I'm dealing with. And if I simplify this, I know that I can divide both top and bottom by 9. So I'm going to divide both top and bottom by 9. So that's going to be 5. And if I divide this by 9, that's going to be 40. And I can divide this further by 5. And that leaves me with 1 and 8. And if I divide 144 by 8, that leaves me with 18 and 1. So the amount that's missing is 18 pi inches squared. Okay, now that we're trying to compare which is a bigger number, well, 50 divided by 3, let's put that into mixed fraction. How many 3's going into 50? That's going to be 10, 18 times 3 is, oh no, 7, no, 6. 18 times 16, 6 times 3 is 18, so that's going to be 16 and 2/3 pi inches squared. Which is a bigger number? 18 is a bigger number than 16 and 2/3. So I know that I am missing more pizza with the bigger piece than the smaller pizza. Okay, so even though the angle measure is bigger, when you actually calculate the pizza, I am missing more from B. So please take notes here. Okay, central angle and sector. We're going to learn some vocabulary. Central angle, you've come across this central angle before. A central angle is an angle made by two radii of the circle. Its vertex is at the circle center point P. Okay, so we have one radii here and one radius, another radius. The angle it makes at the center of the circle is called central angle. Does this sound familiar? Where do we come across central angle? Then when we're talking about the regular polygon, we also came across central angle. Do you remember the word radius on the regular polygon? We said that was the distance from the center to the vertex. But with the circle, radius is distance from center to any point on the circle, because it's all equal distance. Whether it's radius here or anywhere, it's going to be same length. Okay, so radius is how that word comes from. Central angle was the same thing. It's an angle formed by two adjacent radii. Okay, with regular polygon, you have limited number of radii. With circle, you have infinite number of radii. So central angle is just angle that is formed in between two radii with the vertex at the center of the circle. Okay, and then another word that you should know is a sector. What is a sector? It's a slice of the circle. So that is the area bounded by two radii. So this shaded orange portion of the whole circle is called the sector. So you can think of this as a slice of pizza. And formula for area of a sector. Okay, we're really dealing with a fraction of a whole circle. So the area of a sector AS is the fraction of the area of a circle A. The central angle theta of the sector determines the fraction, and therefore the blue sector AS is calculated as this formula.